And incidentally, as we go along, we'll be more interactive. We'll be looking at more examples, but this is sort of story time, setting the basis for what statistics is all about. And I want you to, I think one of the most important things for learning this is for you to visualize yourself using these concepts that we're going to look at someday. So, yeah, what is research about? Research is just you've got a question and you want to find an answer, right? Go to your phone and you Google something or you use a search engine, that's research. You're looking out for some information about this. I've got a question, I want to get it answered. That's research. What we're going to look at is a very systematic way of doing research. So we looked at the overview of statistics. We looked at the types of data we could collect, because that's a very important part. If you want to answer that question, you got to say what kind of information is going to answer that question. And when you do some kind of a study, you're going to collect some data. You got to make sure that the data that you're collecting actually will answer your question. Because I'll tell you what, it's a lot of work to get through the data collection part, and then you look back, oh, I should have asked this other question. You can't go back and do that again. So this starting part, so data collection, experimental design, and then bias. How do we address bias? Because we all have bias. We have two kinds of bias. Does anyone know what the two kinds of bias we carry with us are? There's the, I can't remember the official, there's a kind that you know. I know I'm biased to pepperoni pizza. When I get pizza, I want pepperoni. I'm biased. I don't like those veggies and stuff. I just give me pepperoni, right? So there's a bias. So there's biases we are aware of. And then there's the hidden biases that we're not really certain about. And we have both kinds. Which ones do you think is the most important to address when you're doing a study? Ones you know about, you'll probably address, right? Ones you don't know about, you might not think about it. So that's why some of these things we're going to look at will address those hidden biases. And of course, the more you learn about yourself, the more you'll understand about bias. So we've done the first two. Let's take a look at the objectives. What we're going to look at today is the two main types of studies. There are other types, but if you're going to think about setting up a statistical research study, these are two main types. A third one would be researching like literature. So you go to the library and stuff is already there, but these are two sort of active types. So we have observationals and experiments. What would you think is the key part of an observational study? It's in the name. Observation. Good. Yeah, just watch it. You know, it's a non-invasive one though. You're not doing things. You're just observing. You're watching. You're recording. Okay, so that's one kind of study. So then the experiment must be doing what? Interacting. So it's more invasive. You've got a plan and you're going to do something, right? Observational, you've got questions, you're just going to sit back and listen. Experiment, you got something to do, and then you're going to collect that data off of there. That's the key part. We're going to look over ways to do studies. So there's a survey. There's also simulation, which is using computers. We'll talk about those. And then we talked earlier about the importance of getting a representative sample for a statistical study. So a sample that represents the population, right? And so we're going to look at methods to do that. So sort of, I think, I can't remember, it's 5 or 6 steps. We'll see by the time we're done. But the first part, remember I said where you got to start, you got to identify sort of the population, but not just the population. What do you want to know about that population? Those are what we call the variables. They're the things you're going to change. It could be opinions. It could be some physical characteristic. How tall are these people? How long is their arm? what are their shoe sizes. There could be all sorts of things like that. So it could be physical measures of things, could be opinions. What do they think about the economy? Whatever it is, you have to decide what are the variables you need to know. And that takes some time, especially you want to design a program to improve a school program, right? You want to improve education. Well, there's a lot involved in that, so you got to choose what are the things we need to measure, what information do we need to get from our students that will help us make a better educational system. Okay, so you got to think of those in advance. Once you've got that down, then you've got to develop a way to get that data, collect the data. Remember, if we're dealing especially with large populations. Now, if I could make this classroom my population, that's all I'm interested in is doing a good job for this particular classroom, then I could maybe actually not have to sample. I could maybe deal with the whole population, but I still might want to sample. But if I'm looking at improving all of education, let's say, even just for this college, I'm still going to need a sample, right? So we're going to need to make the sample, make sure it represents the population. So that means that everyone that's in the population is reflected somehow in that sample. Okay. Then we go collect our data. If you're in a graduate program, these first two steps could take like, say, a 4-year doctoral program. The first two steps take the first 2 years. You don't get it. Actually, sometimes it could take 3 years. You don't even get to start collecting your data until you've gone through those first two steps. You learn a lot about things, and you learn how to analyze the data too, because before you collect the data, you have to know what you're going to do with it. So again, before you go to collect the data, like I said, it's probably a 2 to 3 year period of time. Then you collect your data, and then it goes pretty quick after that. But after you collect the data, then you're going to do some descriptive statistics. We will focus on doing that in chapters 2 and 3. So we'll learn some techniques for doing statistical descriptive statistics. And then from chapters, I think it's about 4 to 9, we'll learn some techniques to do inferential statistics, where we take those sample data and we can then apply it to the population. I would, again, I would take my sample from maybe a few classes, get the feedback, analyze the data, and then hopefully, if I've done everything right, I could take that data and say, these are the things that we need to do to improve, and I apply them for the population. Apply it all the way through the school or the college systems or something, and hopefully, if all works out well, we see some improvements. So it kind of makes sense. There's kind of two sides to this, 3 steps, but the first 2 really take the most time, because you have to plan everything. I used to be in the insurance business about 9 years, and we used to have the saying, you either, what was it? If you fail to plan, you're planning to fail, right? So the planning stage is always the important thing. If you have a good plan, you can follow it. But if you have no plan, you've set yourself up for failure. You won't know when success comes if you even saw it. So setting up the plan takes the most, and then implementing it will just go like clockwork, because you've already got everything set up. And then again, at the end, identify any errors, and we're good from there. Data collection part, observational study. Okay, so this is a study where we are not trying to change anything. We are just trying to understand what's going on. So it's very important that we are not invasive. The types of questions we ask are not intended to change people's opinions, but to record people's opinions. Okay, so they observe, they measure characteristics. I remember early on in my career, we did a project over in Thailand. I had a friend. She was a professor. She was a professor in Chiang Mai University, and we did a project up there. She was working on. Actually, she got her doctorate, so she was Dr. Apple. We called her Apple, and we went to these different schools I had just finished my master's, so I hadn't done any research. But when we went into the schools, I felt we need to help, go and tutor the kids. And so me and my team, we were active in there. Apple was in the back taking notes and just observing. And I thought, that's all she's doing is observing. But now I see the benefit because from her observations, she's actually now the chair of an education program and she's implementing some changes. So, well, sometimes you say, well, they're not doing anything, but they're observing. And then from that, you can gain a lot. So something like you could sit and measure the time people spent doing various activities, things. How much time do they watch TV? It's just an observation. How much time does they spend on the homework? How much time do they spend on this or that? And then you just record it. Again, you're not telling people to do one thing or the other. You're just recording what they're doing. That's an observational study. Now, experiment is different. And there's two types of experimental studies. So we'll take, or not two different types of studies, two types of experimental units. When you're doing an experiment, you are bringing in a treatment of some sort. So we think of it, if we think in terms of medical things, taking a medicine as a treatment, trying to make some disease go away or something better, right? So treatment. And so in this case, what we have to measure is the effect of that treatment. In an educational setting, the treatment might be a particular way of teaching or a particular way of doing things. But to measure if the treatment itself is effective, what do we need? We need something to compare it to, right? Did it make things better or worse? So we need a treatment group, and then we see what happens to that group. But then we also need what we call the control group who did not get the treatment. So what's the difference between no treatment and the treatment? So we have two groups to compare from. So experiments, that's one of the things you'll see about them. You can identify them. There are always these two groups. Now, sometimes the control group, it just means we just did nothing to them. But sometimes we do something called a placebo. Does anyone know what a placebo is? What's another word for placebo? A what? It's an illusion, right? It's a sugar pill. So if you're doing a medicine, it's a fake pill. So people don't know that they're getting the medicine or not, because those of you, I think in this class, there's a few of you going on to psychology, right? And if not, we all know about psychology because that's what we live in. But our mind, if we think we're getting something that's supposed to make it better, a lot of times our psychology gets it to improve or not improve. But there's a psychological component that gets involved. So if I'm just taking a pill and I don't know one way or the other, we're able to measure more accurately. Okay. Was it my psychology that made me get better, or was it actually the treatment? Okay. So let's see if this is an observational, or so this is kind of like a homework type question. Researchers are studying the effect of vitamin D3 supplementation on patients with antibody deficiency or frequent respiratory tract infections. 70 patients received 4,000 international units of vitamin D3 daily for a year. Another group of 70 patients receive a placebo daily for 1 year. Is this an experiment or observational? And why? Yes, sir. Excellent. So key part, there's the two groups, right? You'll see that, and there's a treatment and a placebo, which is a non-treatment, but psychologically it's a treatment to make them think they're getting something that's a fake thing. So, and then we could measure, does taking D3, vitamin D3, does it help or hinder? Is there any ethical, because I want you to think about doing things, these are people, these are human beings that we're working with, right? It's a whole year long. Is there any potential ethical issue here? of the way because we're giving some vitamin D that we think is going to help. We're making sure some others don't get vitamin D. Could there be ethical issues? What if it turns out the vitamin D was really, really helpful, kept them from getting sick? Maybe we found that out in the first 3 months, but we kept it going for a whole year. What are we doing to the people that have the placebo? We might be setting them up to get more infections, right? We get this information. Hey, this stuff's really helpful for these other people. They're not getting sick. These other people who are the placebo think they're getting the treatment. They're getting sick more often. And we're doing this whole experiment for a whole year. So there's issues here. And what we want is we want ethical research. And just because all the rules don't always guarantee that. But I want you to think about when you are, especially if you're doing lab type experiments on people, remember they're human beings. And so sometimes withholding a treatment that is of value can be unethical. And there's a whole case of this. If there was the Tuskegee case where they did that with, and it was racially biased as well. Okay, but yes, there's a treatment, and then there are the two groups. How about researchers conduct a study to determine how confident Americans are in the economy? Researchers called through 3,040 US adults and asked them to rate current US economic conditions and whether the economy is getting better or worse. Observational or experiment? Observational, right? Why? Okay, and you don't see two groups, right? They didn't say they broke them up and called these people and said this and these people said that. Now you could turn it into an experiment by saying, well, we'll split these up and half of these will ask the question this way, half of this we'll ask the question that way. Then you're saying, is the way we ask the question an effect? So there's actually a treatment, but in this case, we're asking them the same questions. It's just observing. We just want to know what their opinions are. No treatment, observational study. And that's why the third one that I mentioned is actually also an observational. So if you go into the library to do research on existing cases, this is called a case study thing. You go in and data that's actually already been collected, you go pull out certain parts of it. That's actually part of an observational study. Because again, you aren't doing any treatment, you're just observing what data has already been out there. So you could actually do an observational study of an experimental study if you just go in and look at their data and maybe do a different analysis on it. That actually qualifies as observational rather than experimental. Okay. So again, we talked about, we define our population. It's usually a larger group. So we need to get our data from there. And one way of doing it is using a simulation, like on a computer. Maybe we'll talk about probability a little bit later, and we call them probability experiments. We want to see how often, like maybe rolling dice, how often does the number 3 come up when we roll a die? Well, we could roll a die 1,000 times, 1,000,000 times. That gets a little tedious, right? We can also set up a computer program that will do that, and as long as the computer's working right, we could have it roll it 1,000,000 times actually pretty quickly, so that running it out. So there's simulations that we can use computers for. This is especially helpful for dangerous situations. It can save time and money. And one of the areas this is used is car makers. They used to do a lot of crash tests with dummies in there with sensors to see what kind of damage was done to the dummies, not putting a human in there doing these chromosomes and stuff. As the computers have gotten better and faster and they've gotten this data, they're actually able to do a lot of that through the computer. So they're actually not having to crash a car, which is kind of expensive, right? So instead of spending a brand new $30,000 car or $50,000 car, whatever, and crashing it and destroying it to see what it was, they can run a lot of simulations and get that same information. They'll still probably do a physical crash test at some point just to prove that that worked out. But again, computers can oftentimes, if everything's put in there, can do experiments for us. What if we change this? How does that affect? Okay, so simulations. Another way we collect data is through surveys. So we talked about when we're doing a survey, remember that is a sampling in itself. Does anyone remember if we send something out to the whole population, what is that called? A census? Yeah, so that, again, every 10 years they take a census of the United States where their attempt is to count every person in the US. So that's a census. So just remember the census is trying to get information from everybody. You could do that like in Congress, they will do a roll call thing. That's really taking a census of their opinion, their vote, because the Congress is the population in that case. Okay. But for larger population, we do a survey. So we're trying to get one of the characteristics of the populations. We're just asking questions. So this is going to be a observational study, commonly done with interviews. You could do it over the internet, phone, or mail. There are some drawbacks to each one of these. One of them is participation bias that can creep in because some people might not answer it, right? Some people might answer it. And actually there might be a group of people that have similar ideas that don't want to take it. So there's all kinds of biases that can come in. We'll talk about that later. But designing the survey is really important, to take the time. The way you word the questions, that's important. The order of the questions, that's important. When you go to graduate research, there's actually a whole class on writing a survey. I took a 3-credit class on writing surveys, and you get into the deep part of leading questions that might elicit a particular response, biased questions, question ordering, all sorts of things. And then you have to write several different surveys on several different things. So again, something that's very important. But if your survey is missing something and you send it out and you get it back and you notice, oh, I should have asked this, this, and this, are you going to be able to do that? Probably not easily, because however you did, you spent money to go collect, mail things out to get it back. You wouldn't necessarily be, and a lot of things with surveys, we try to keep them anonymous, so you won't know which person answered this way or that way. So that's the thing, is you've got to spend your time to make sure your survey is ready. You can't just throw it out there and do it. Otherwise, you pretty much have to start over. Okay. Surveys conducted on a sample of physicians to determine whether the primary reason for their career choice is financial stability. So there's a survey. Did you become a doctor because you like the money? Designing the survey, would be acceptable to make a list of reasons that each individual in the sample to select their first choice. So sometimes you want to ask open-ended questions because you want to just get those. Sometimes you want to put like a multiple choice because you're trying to see which one's more favored. If you have a list of them, a lot of times it's helpful to have a choice that is other, so that you could see, well, maybe none of these really fits their situation. And so you could count that as a last one. To do a good experimental design, so that was observational. For experimental, there's sort of 3 things that are needed. First is control. So you have to have controlled settings so that other things that might not influence it. Randomization is important. That helps with getting rid of bias. And then replication, being able to do the study again. So you have enough detail that somebody else can do the study and either validate what you did, say, yeah, what that study came up with is correct. Vitamin D3 does help reduce or does improve the immune system or not. Okay. And again, with all of these things, I always think about educational research. I've been on grant programs where we did all of those things, but then it's not a real classroom anymore, right? you do randomly putting, because people don't come to a classroom. Um, you take away the realness of it, and of course that causes problems with the research base. But again, some things I want you thinking about when you do your research, that just because they say this is the gold standard for research and this is how it's done, and so sort of taking this lab approach and this control and this, that might not be appropriate for the things that you're trying to research. Especially, so there's a whole field of research, and this is kind of, if you go through a research program, a lot of times you have to go look for those types of things that is doing research in a real setting and looking at ways of getting data out that is not invasive, but that sees what's really going on. One of the reasons, though, that many experimental designs have to have the controls is something called confounding variables. So things we're not necessarily thinking about or measuring, they could affect the outcome of a study. Okay. We have a fertilizer and we're testing plant growth, which one helps the plant grow better. What might be a confounding variable? Maybe how much light the plants get. So maybe in our lab, we've got some plants on the side that are close to the window, so they're getting extra sunlight from the ones that are maybe a lot closer to a wall. And we didn't think about that. And maybe the ones closer to the window all grew taller, and we think, oh, that fertilizer is the one that's working. Maybe it's not that. Maybe it was the sunlight that we didn't control for. Okay, so that's the need for controlling so that other factors don't come in. We're just testing the one thing we're wanting to do. Okay, there's examples here. Coffee shop owner remodels her shop. At the same time, a nearby mall has its grand opening. If business at the coffee shop increases, is it because we did a remodel, or is it because of the mall opening? There's these two things we're not able to tell the difference. Of course, we don't care. Our business went up, right? But when we're doing research, we have to, if we're looking for the reason, we've got to look out for those confounding variables. Using the placebo can help against this. So placebo effect occurs when a subject reacts favorably to a placebo, when in fact the subject has been given a fake treatment. So this happens. Some people, just get better, but because they're taking this medicine, especially like weight loss thing. Okay, I'm taking this weight loss thing, losing weight, but maybe by taking it, that gets your mind thinking, and you're reducing your food intake, you're exercising more, whatever, you lose weight, not because of the pill, because the pill was a fake pill. Okay. So one of the things they do is when you do a placebo, it's important to do what they call blinding. Blinding means that there's two meanings to it, but it means that they don't know whether they're getting the placebo or the treatment. And there's two kinds. So it's kind of at the top. It's my blindfolded picture. So the one type of blinding is just the participants themselves do not know whether they're getting the placebo or the treatment. So we went through COVID not too long ago when they were testing vaccines. They did this. Some people got an actual vaccine. Other people just got, I don't know, water or a saline solution pumped into them that did nothing. The people that were getting it did not know. Now, again, ethical issues. At the time, COVID and such, people went out. People may have thought they got a vaccine, but maybe they got the placebo. Of course, everything was on lockdown at that time, for the most part, when they were starting. But again, ethical issues. So blinding, one-sided blinding, the participants don't know. Sometimes the treatment is the way you measure the success of the treatment is by observation. So maybe, let's say you have an anger management program, and then you do it as an experiment. So one group is getting the anger management, the other group is getting some other kind of class that is not really anger management, and then we want to see if it makes a difference. Well, how can you tell the difference if they're managing their anger? Somebody has to observe them And so that researcher that's observing them, they might be biased if they knew that, oh, these are the ones that took the anger management, these are the ones that didn't, right? And so in that kind, we do what's called a double blind. The researchers who are measuring also do not know. So the doctor involved has blinds on. They don't know who got the treatment and who didn't, okay? Because their measurement might be biased by knowing one or the other, especially if money's involved, right? Okay, they took the medicine, and if we get this medicine approved, we're all going to be rich. So we'll skew the data this way. Maybe not thinking of it that way, but maybe that's how it goes. So a lot of times you'll see double-blind studies, and again, it works in laboratory type settings, but are not really very helpful in a real world setting, especially like educational research. Okay. So far we good? Okay, so blinding, single blind, sometimes that's necessary. A double blind is great if you can fit it in. It's not that nobody knows. There's usually you'll see like medical experiments, they'll put coding numbers on samples that are taken. And so those go to some lab. The people at the lab will know from those code numbers whether they got the treatment or didn't get the treatment. But the people who are doing the drawing, the people who are in the study would not know, double blind. Another thing that's important is something called randomization. And what that helps do is if things are truly randomized, we are more likely to get a representative sample. We're less likely to get bias. If we are choosing our participants, oftentimes our bias will enter in. Okay, the researcher's bias can enter in. So there's randomization, there's a process, and usually a computer's used in some way to assign random numbers to participants, and then they either go to the control group or into the experimental group. Completely randomized design that subjects are assigned to different treatment groups through random selection. So each person in the study could go to one side or the other. There is also called a randomized block design. This sometimes helps with ensuring that the characteristics are there. So you have participants with particular characteristics are the same, they're all in one block, and then you randomly assign subjects to each of the treatment groups within each block. So an example of that would be something like this. We want to see the effect of our medication or whatever it is we're testing on different age groups. And so we break our participants into those age groups. We've got them into blocks, 30 to 39-year-old, 40 to 49, over 50. And then from within those blocks, then we randomly assign those people of those various age groups to either the control or the treatment. So we're testing two things. Does our treatment work better than the control? And also, is there an effect over age? Does maybe younger people have a better or worse effect? Is there an age effect here? So it's called a block design. Another way is to sort of, it helps with getting representation and also the fact that when you're doing an experiment, you want your experimental group and your control group to be very, very similar so that there's not some feature that is again, some other thing that's not getting measured. Maybe put all the taller people in the experiment group and shorter people in the control group, and whatever you're testing, that might make a difference. So we want the two groups to look as much as possible. So one way of doing this is you go into your group that has been randomly selected, and you pair them up, and you get two people that are very similar in whatever aspect you're trying to do, and then you randomly select one to go to the treatment, the other to the control, and you do this pair by pair. Okay, so you pair them up. These two are very similar, so we'll randomly put one in the control, one in the treatment. And again, that helps make sure that your treatment group and your control groups are similar. Sample size is very important, and when we get a little further into our the calculations that we're going to do, probably not till chapter 4, but what we look at is the effect of sample size will affect our statistical tests. And so oftentimes we need to, in fact, you'll do these calculations, you'll say if you want your results to have sort of, first of all, there's always going to be some kind of error. But if you want to limit your error, you get a larger sample size. But larger sample sizes oftentimes are more expensive and more time consuming to get. So we do this thing of what size do I need to get the results that I want? So we'll do this backwards calculation. You can determine that sample size at the beginning. So, and we'll see that there's a rule of thumb is about 30, because statistically, after 30, the way we do our calculations, a lot of things become very similar. Under 30, there's actually 2 different approaches that are needed for the calculations. So sample size is important, and we'll take a look at that. The other thing is being able to repeat the study, so replication, especially with large groups. So if you test a vaccine of a strain or 10,000 people, another 10,000 are given a placebo. This is a fairly robust sample size, and so it's probably going to apply. If you do it on smaller groups, that might be like initial stage. That's why a lot of studies will be done in stages. First stage is to see if it's safe. You don't want to go 10,000 people if we don't know if it's safe yet. So to do small, but to see if it's really effective, often for these medical research, they need very large sample sizes. And then they need to be able to repeat it. And so that's why oftentimes there's 3 or 4 stages, smaller group, see if it's safe, everyone's okay, make it a little larger, and then once they get there, they can go. So sampling techniques, this is where we're going to look at several different ways to pull a sample. And there's sort of a trade-off between the ease of getting the sample and the benefits, how much that sample is going to be representative of the population. So first, we get to the word census. I told you we'd get to there eventually, but the census is if we do something with the entire population. It can be done, but not very often, right? We do that. The government does that every 10 years, where they try to take a census of the United States, count every single person, what's your gender, your age, all these demographics. So that's a census. Sampling is taking part of those people, part of the group, and trying to do some statistical analysis on them, and that's what we will be focusing on. Even with the best methods, it brings out there's always the potential for sampling error. A sampling error is when our sample really is not representative of the population. We got too many of this kind of a characteristic, where maybe in our sample 50% of this characteristic, where in the population maybe only 20% have that characteristic. So we're trying to balance things out, but we could still get sampling error. Okay. So one way to address this is to do what they call a random sample. Simply put, a random sample means everyone in the population has the equal opportunity to become part of our sample. So again, a computer assigns a number, randomly those numbers are chosen, and then we choose those as our sample. That's one method, okay, completely random. Simple random sample is that every possible sample of the same size has the same chance of being selected. So it's, if you were to do it again and again, and you're looking for a sample of 30, every sample has the same chance of being selected. And while it sounds easy, let's just get a random sample, that's actually not very easy to do. So there's, again, you'll take, if you go into a research-based graduate program, you'll spend a whole class on sampling, right? So You'll spend a whole class how to write surveys if that's what you're going to do. You could spend a whole class on sampling methods and how to actually get a random sample. So random numbers are generated from a computer, assign it to each in the population, and then those members become part of the sample. But what if someone doesn't want to, right? That happens. So that's why sampling bias can occur, sampling errors can occur, because we selected them random, but some of them didn't want to participate. So we had to select some others. Okay, so that's how it happens. So there are 731 students currently enrolled in the statistics at your school. It's probably pretty close. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. So the way you could do it is you assign each student a number, since there's 731, 1 through 31. And then they actually print these tables of random numbers, because again, there's random features in computers, but they're not truly random. Getting truly random numbers is difficult. But there's tables of values that are random. And we'll do an example of this a little bit later to see how when we get into it, to see the use of this. But then you're able to randomly choose your sample. So I'm not going to, this was for the other course had some of these. We'll do this a little bit later when we're actually doing it, but the way a simple random number randoms would work is that 719, we had 731, so we're looking at 3 digits, so we would take participant 719. So notice we started at sort of a random place, and then we would use the next 3 digits, 662, that person would get chosen. 738, we had 737, so 738 is too big. We can't use that. That's not in our group. So then we go 650. So we just kind of go through, and these numbers are all random, but we take them in blocks of 3. 004 would be the 4th. And so then we keep doing this until we have our 8 participants. We go contact them, and hopefully they all agree to be part of our study. If they don't, then we have some alternatives maybe lined up. Okay, so that's how we could use a random number table to actually go ahead and do it. So they block it just like that. In our homework, we don't have a problem like this. They had it in the MyMathLab, which we're not using. Okay, but we'll do a little activity a little bit later on getting random samples where we use this technique. Okay, another method, stratified sampling. Okay, so we divide the groups into strata and then select a random sample from each group. So this helps keep things representative. This is a example using income. So low income, middle income, high income, however that gets defined. That's you put your groups into that. And then from each one, you select your random sample from each of the groups. And so then you're making sure that your sample is representative of the larger population. Okay. Notice that they've got in the middle income group, they're selecting 3, low income 2, high income 2. So maybe there are more in the middle income. So you can, again, try to keep your sample as close to being like the population as possible. So stratified, you put them into their strata. You could also do it with male and female, because maybe that's something of interest. You want to have an equal number of males and females. That's another way to stratify them. If you're studying college students, maybe by year in school, various ways to set up those strata. Okay, example there. Okay, but then the important part is once you have the strata set up, the selection from within there is done with random selection. Again, it helps to deal with bias. Cluster sampling. It's a little different than stratified. what you do is you divide the population into what we call clusters, and then select all the members in one or more, but not all of the clusters. So you might put, a lot of times this is done by area. So you're studying an area, so you could maybe choose 10 zip codes. You randomly select 4 of the zip codes, and then everybody in that zip code would become part of the study. So there's a randomness to it, but the clusters, it's either everyone in the cluster is in the study or they're not in the study. Okay, so that's the difference with the cluster, that there's no random selection within the cluster. The cluster itself is either randomly selected or not. So that's kind of different from the stratified technique. So yeah, zip codes, take everyone from zone 1, they're in the study. Again, you could see some potential bias here, right? If you only have some from this zip code, you're going to get a particular type of answer potentially. Systematic sample, this is oftentimes used in manufacturing for quality control. You check every kth member, every 5th item down the production line, or they every 10th or 12th, whatever it is, but it's systematically, that's how you take your sample. I remember when I was a kid growing up, I'd go to the mall. I lived in Oregon. We didn't have air conditioning because usually it was only like 2 weeks in summer where it got hot enough you needed it. We didn't have it, so I'd go up to the mall right up the street. They had air conditioning. We'd hang out all day. We were called the mall rats because we were just kids hanging out at the mall. They also had a research place, and so we thought for something to do, I walked up to, oh, I'll take your survey. He says, no, you're not the 5th person that came up to me. So they, and I, I'm a kid, I didn't know what that meant. But now I look back, that's what they would do, is they would take random samples, they would watch people, and sometimes they would use a systematic sample. They could only take every 5th person. They really, you'll see for sampling, you really don't want people who are volunteering to be, because then, yeah, I probably would have messed it all up. I'm just a kid who's, what am I going to say about their surveys? But systematic, you take every so many, okay? And that was an example. So again, here it is. You could do it with households, house numbers, whatever, and they're taking every 100th house. Okay, those will form our sample. Could be issues with this type of sampling, but again, it also might be okay if your areas are close to your population. Okay, this is probably the worst kind of sample, but it's also the easiest to take, a convenience sample. So I want to find out something. It's easy to get. You maybe just, here we are, let me ask you all a question. This is now a convenient sample because it's, what do you think about multi-factor authentication? Because that just went into effect. Or when did you have to start using multi-factor authentication to get into the college stuff? You have to use your phone, don't you? So when you log in, you got your phone. That, I think it started last year, or has it always been going on? I don't know. Well, what's your opinion? So anyway, it doesn't really matter, but so that could be it. I'm asking you just because it's convenient. It's not scientific. I couldn't go back to my department chair and say, hey, my students really hate this. Can we get rid of it? If we're going to do that, we're probably going to want to do some other type of sampling to make sure it's across the class, across the college. Okay, so would it be safe to say that if I just use this group here as my sample, it might not be representative of the whole college? So that's why it often leads to bias. And yeah, you divide the student population with respect to majors and randomly select and question some students in each major. Okay, so what kind of sample would that be? Look at the college, break them into majors, and then we random select and question some students in each of the majors. Remember all our choices? Yes, sir. Very good. Very good. It's not a cluster because cluster, you take the whole cluster. We take individual majors. So yes, when you do random within the strata, that would be a stratified sampling. Very good. Okay. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. What kind of a sample is that? Not quite. Remember, systematic is every 5th or every 10th. It's a random sample. So it's kind of like so it's almost too obvious, right? If you randomly select them, it's now a random sample. And it's a simple random because the way you've done it by assigning that number, you get each person has the same probability of being selected, and each sample has the same probability as well. What's going on? Getting lots of emails. I thought I disconnected these two. Do this. I turn off my phone. Okay, so that's a simple random. You select students who are in your biology class. Yeah. So you just chose them because, hey, I want to find out. Ask everybody. That's convenient. So it's convenient to do so easy. Again, it may have bias because it's only going to be those groups, but a lot of times it does give us some sort of answer to start with. Hey, where's the best place to eat around here, right? Might get a good idea. Might work just to ask. I wouldn't necessarily set up a whole study to find out what's the best restaurant, but so that's it. So what to avoid bias. So we're going to talk about different types of bias. Remember, there are two types in general, the kind we know and the kind that are sort of hidden biases. And sometimes we hide them because we don't want to think we're biased, right? But we all have our biases because of our interactions. But bias is a systematic error in the collection of the data that can lead to inaccurate results. What causes bias? They could be the design issue. So in the beginning, if we didn't design things right, we could have confounding variables coming in. We could have some different things affecting our study. So if we don't have the right design, so they call them either lurking or confounding variables. So again, if we're testing fertilizer and how quickly it makes something grow, we also have to think about how much water are they getting, how much sunlight. We've got to control all those things. Otherwise, one of those other variables could make the difference, and it's not really the fertilizer. Overgeneralization, when a study is done on one group and applied to all groups. And we'll look at this. There's statistical techniques we need. Sometimes we get a result, and it could just apply to the group that we had it on. If we try to apply it to everyone else, if our group wasn't representative, we're going to have a bias because it's not going to work for every group. Okay. There's sampling bias, so if we don't take a good sample, and again, convenience sample is one very prone to biases, but even random samples can somehow get some bias that slips into it. So sampling bias. Self-interest study, I've spoke about this a little bit. If like a researcher who's getting a grant money, especially medications, and they can make a lot of money if this medicine is approved, there's that self-study bias. So the researchers may try to either massage the data or make it look a certain way because they have a benefit. So one of the things that you learn is to look at who did this study. There's a lot of things on gun control. You've got to look at who did that study on gun control, because one side, they may be favoring either controls or not controls, and the data may reflect that. So there may be a lot of bias and stuff like that, especially politically motivated studies. You've just got to be real careful who did it. Were they really independent? And even some people who say they're independent, they aren't. They're actually bringing it in there. This is the other one, voluntary response bias. People who says, I want to be part of your study. Usually those are the first ones that get rejected. Sorry, if you want to be in it, you can't be in it. Now there are other ones that, they look for certain conditions, and so they are looking for volunteers to come forward because they're studying a medical treatment. But when opinion surveys, the worst thing to do is take people who are volunteering to get in there, okay? Because that brings in some bias, or it can, okay? Non-response bias is those ones we select, but they don't give their opinion, or they don't answer all of our questions. We don't know what they think. Maybe we know it on a few, but they either refuse to participate in the study or don't answer some of the question. That brings in a non-response bias. And we'll have these out there, you'll kind of see, but just the main thing I want you to see is the different types that are out there. There's also response bias when the person is giving an inaccurate answer, sometimes because if there's not like privacy and stuff, I'm just going along with the crowd. I don't want people to know what I actually think. So sometimes you get inaccurate responses, and this perceived lack of privacy, I can't say that word very well, so I'll skip it, but privacy, again, they don't give the right answer or the true answer that they believe, because they feel, your employer is asking you, how do you feel about your job? Oh, I love it. You might answer that whether you do or not, because you want to keep it, right? So there we go. Also, there's loaded questions, and these are the types of things when you take a survey class, you'll get into them. Loaded questions are ones that guide the respondents to answer in a particular way, because you might try to make, well, if you answer yes, then you're like a jerk, and answer no is the right answer. So the way you ask the questions can make a difference. And then even the order of the questions. So sometimes you could ask them in a particular order and you'll get a particular response. If you change the order, you might get different responses. So there's a whole science on setting up surveys to try to avoid leading questions, loaded questions, and also looking at the order that the questions are being asked in. So all those have create different situations. So remember, you have access to this through Canvas. So again, you can copy and paste it. We're not going to I'm not worried so much about testing and how well you do with this. It's the homework is, so you can remember, I got to check back. Did I tell you about testing and getting a page of notes? I didn't mention that. Okay. When we go to our tests with statistics, every statistic class I have, you get a page of notes, one page, front and back, regular sized piece of paper where you can put whatever notes you want. So as we get closer, we'll do a practice test so you kind of know what it's about. But if it was going to test you on bias, you might want this list of questions in there. I don't think I have anything specifically about identifying biases. Sometimes it's in the homework. Again, you could use it. You certainly, while you're doing the homework, use your notes. But testing, you'll be able to use a page of notes as well. So, what we're doing, yeah, perfect. We're right at 10 o'clock. If you, oh shoot, did I ever start? I did. I am recording, good.